everyone, welcome to Ganit Academy and multiply your success here. Today's topic is derivatives of inverse trigonometric function. In previous video we have seen derivatives of inverse function. Now next point is derivative of inverse trigonometric functions. Okay, like sine inverse x, cos inverse x, tan inverse x, like this. And in this video we will see what is the derivative of sine inverse x. How to find out derivative of sine inverse x. Okay, see, if this is given y equals to sine inverse x, here x lies between minus 1 to 1 and y lies between minus pi by 2 to plus pi by 2. Okay, now we have to find derivative of sine inverse x, means we have to find dy by dx. So we will go through the method of derivatives of inverse function. Here consider this y equals to sine inverse x as, shift this sine inverse here, we will get sine y equals to x. Okay, this is very simple. Write like this, x equals to sine y. And here also x lies between minus 1 to 1, y lies between minus pi by 2 to plus pi by 2. Now differentiate this x with respect to y. Differentiate x with respect to y. Derivative of x, dx upon dy. Derivative of sine y, that is cos y, as plus minus square root of cos square y. Because square root and square gets cancelled, we will get cos y. And ऐसा क्यों करना है, मतलब cos y जैसा है वैसे क्यों नहीं लेना है? Because अगर trigonometric identities यूज करनी है तो square functions चाहिए, इसीलिए ये adjustment है. So here plus minus square root of cos square y we can write as 1 minus sine square y. Because identity sine square y plus cos square y equals to 1 from that. Now here plus minus square root of 1 minus sine y. From this equation we can write instead of sine y x. So write here in place of sine y x. Here it is square, that's why we have to write square. Okay, now what about sine plus minus? As this y minus pi by 2 to pi by 2, this y lies between second quadrant or fourth quadrant. That's why it is always positive. Means we will take it as positive dx upon dy. But you know that dy upon dx equals to 1 upon dx upon dy. Now substitute the value of dx upon dy. 1 upon value of dx upon dy. It is square root of 1 minus x square. Square root of 1 minus x square. Means what to write? d dx. Value of y is sine inverse x equals to this 1 upon square root of 1 minus x square. So this is the derivative of sine inverse x, 1 upon square root of 1 minus x square. In this way we can find our derivatives of inverse trigonometric function. What to do? First step, just write down given inverse function like this. Means sine inverse x equals to y, in place of that sine y equals to x. Okay, here we get value of x, x equals to sine y. Now differentiate this x with respect to y. Means dx upon dy equals to cos y. Now we don't have any identity in cos y sine y. But we have identities in terms of cos square y, sine square y, like this. That's why we have to adjust here cos y equals to square root of cos square y. Now use the identity 1 minus sine square y. After that, here we will use only plus sign because this y lies between minus pi by 2 to plus pi by 2 means second quadrant and fourth quadrant. Again, in place of sine y, this we can write in place of sine y x. Here we wrote 1 minus x square. So this is the value of dx upon dy. But we want dy upon dx. Dy upon dx is always equals to 1 upon dx upon dy. Substitute the value of dx upon dy, that is square root of 1 minus x square. Again, ddx of value of y is sine inverse x. Write down sine inverse x. After that, its value is 1 upon square root of 1 minus x square. In this way, we can find out derivatives of cos inverse x, tan inverse x, cot inverse x, sec inverse x, cosec inverse x, like this. Okay, thank you.